Hello, area of circles and area of sectors today. The area of the circle, remember guys, area is the number of square units that fit inside of the plane figure. And to find the area of the circle, it's going to be the product of pi and the square of its radius. Product, remember, means to multiply. So we're going to multiply pi times the radius squared. For example, in this picture here, if we said the radius of this circle is 5 inches, then to find the area, we're going to take pi times the radius squared. So pi times 5 squared, which would be 25 pi inches squared. Remember, that is the exact area. If you have it with pi, that's the exact area. If I wanted the approximated area, I would put 25 times pi into the calculator, and that's going to give me about 78.5 inches squared. Awesome. Area of a sector. First, we have to know what a sector is. And at the top there, it says that a sector is defined as a region bounded by the arc of a circle and 2 radii. So in the previous lesson, we talked about arcs, and they're kind of, I refer to them as the crust of the pizza or the crust of the pie. So here's arc AB. That's one boundary. Then we also need 2 radii, so radius OB and radius OA. This would be our sector, it's the region. Sometimes I'll refer to it as a slice of the pie or a slice of the pizza. To find the area of this, the area of a sector is just a fractional part of the entire circle. Here's a circle. Let's say that the area of this is 100 centimeters squared. If I shade in a fraction of this circle, here, by looks, we would say that that's about half of the circle. So if the area of the entire circle is 100, then the area of half of it would have to be 50 centimeters squared. Let's say I shade in another portion of it. This portion in orange. By looks, that's about 1/4 of the circle. Well, if the entire circle is 100, then 1/4 of it would have to be 25 centimeters squared. Now, the shading isn't always going to be a nice 1/2 or 1/4. So, if I go back up here, it says to find the area of the sector. That's what this part's supposed to mean. Then you're going to take the measure of our arc. So we're going to find the measure. Remember, measure corresponds with the angle measure. So we put that measurement over 360 degrees because it's how much of the entire circle is being shaded. And then we take that fraction times pi r squared. Over on the left side here, when I shaded half of it, my x, my angle measure that corresponds there, would have been 180 over 360 times the area of 100, which is how we got 50. Or my orange shading, this would have been a 90-degree angle, so 90 over 360 times the area of 100. Well, 90 over 360 is the same as 1/4. So, to find the area of a sector, we have to know how much of the region is being shaded, and then we take that times the area. We'll go through a few example problems here. This first one, it says a circular archery target has a diameter of 2 feet. It is yellow except for a red bullseye at the center with a 6-inch diameter. Find the area of the yellow region to the nearest whole number. Yellow region. Now that's just that ring. So to find the area of that yellow ring, we have to find the area of the outside circle, the big one, and subtract the area of the little inside one, the red one. Above, to find the area of a circle, it's pi times radius squared. So I need to know the radius for each of the big circle and the little circle. In blue, I'll do the big circle, the outside one. It says it has a target that's 2 feet in diameter. Remember, diameter is the distance across. So the entire target here has a diameter of 2 feet. So then to find the area, I need to know the radius. Well, if the diameter is 2 feet, then that means the radius would be 1 foot. The little circle. I'll use orange here. The little circle, the red bullseye, has a 6-inch diameter. So right here, this would be 6 inches. Well, if it has a diameter of 6 inches, then the radius of the little circle would have to be 3 inches. Now, what do you notice here? The big circle has a radius of 1 foot. The little circle has a radius of 3 inches. Difference? One's in feet and one's in inches. So in order to do this, they have to be in the same unit of measure. So 1 foot times 12, 12 inches. Now, area of the outside circle. Pi times 12 squared, 144 pi. Area of the inside circle, pi times 3 squared would be 9 pi. To find just the yellow ring, I have to take 144 pi and subtract 9 pi's from that, and I would get 135 pi inches squared. Oh, it says to go to the nearest whole number, so I need to put this in the calculator and round it to the nearest whole number. Ooh. Which is about 424 inches squared. Cool. Sectors here. To find the area of sector ACB, we're going to leave our answer in terms of pi. So on your notes there, you should see that in the box, that to find the area of a sector, you take the angle measure, the arc measure, over 360 times pi r squared. Area means we got to multiply by area. If we're doing arc length, that's when you multiply by circumference. So sector ACB shaded in an orange, the angle measure is 100. So we're going to go 100 over 360 times pi radius squared. Radius 6. In terms of pi, we're going to leave pi in the answer. When I do it in terms of pi, I just like to simplify a lot here. 100 over 360, the zeros would simplify, so then I get 10 over 36, which would be the same as 5/18, times 6 squared over here, which is 36 pi. Remember, when we multiply fractions, we go straight across, so we would be doing 5 times 36 pi in the numerator, and then dividing that by 18. This would create a fraction, so I could reduce it. Remember, I can reduce first. I know that 18 goes into itself once and into 36 2 times. So then when I go to multiply, I would get 10 pi meters squared. Whoops, meters squared. You could multiply 5 times 36 and then divide that number by 18. But again, I like to simplify first. All right. Number 3, how much more pizza is in a 14-inch diameter pizza than in a 12-inch? How much more pizza is in? When it says in, we're thinking area. So for the large, the 14-inch diameter, to find area of a circle, it's pi times radius squared. If our diameter is 14, then the radius would be 7 inches. So then we're going to take area equals pi times 7 squared. So that would be 49 pi inches squared. And in the small pizza, we have a 12-inch diameter. So the radius there is going to be 6 inches. So then the area, pi times 6 squared, gives me 36 pi inches squared. To find out how much more, I'm looking for the difference, so I need to subtract. 49 pi minus 36 pi would be 13 pi inches squared. That would be the exact difference. If I were to put this in the calculator and round 13 pi we get about 40.8 inches squared. A circle has a diameter of 20 centimeters. What is the area of the sector by a 208 major arc? Round your answer to the nearest tenth. I want you to pause the video and try this one here on your own. How was that if you didn't pause it? A lot of silence. Alright, so a circle has a diameter of 20 centimeters, so that means its radius is going to be 10. What is the area of a sector by a 208 major arc? Remember, major just means it's over 180 degrees. You could draw a picture, you don't have to. This is not drawn to scale, but this would be my 208. So we're trying to find the area of the region of the sector that's bounded by these two radii here in red, and then this arc of 208. So we're trying to find the area of this red shaded in region. On your notes there, area of a sector, x over 360 times pi radius squared. Our x value, that's the arc measurement or angle measurement that goes with the shaded region. So that's going to be 208 over 360 times pi radius squared. We know that the radius is 10. This one says round to the nearest tenth. So you guys from here, you could just put this all in the calculator and round it to the nearest tenth. You just have to make sure that when you put it in the calculator, you are doing so correctly. 208 divided by 360, not times 360, times 100 pi. And you should get about 181.5 centimeters squared. All right, for the good ones here. Find the area of the shaded region. Round your answer to the nearest tenth. Shaded region. It's like a semicircle. That's how I would describe it to my 3-year-old son here where we're working on shapes. So to find the area of this semicircle, we have to do two things here. We first need to find the area of the sector that I'm outlining in blue. That's going to give me all of that. So we're first going to find the area of the sector. And then we're going to find the area of the triangle and subtract it. Because if I subtract that portion in blue, then I'm just going to be left with that semicircle. So we're going to subtract the area of the triangle. We'll start with the sector first because it's similar to the one that we just did. To find the area of a sector, you take your angle measure, arc measure, over 360 times pi radius squared. And the radius on this, you guys, is 24. I'm going to wait to round to the very end. Our answer will be more accurate and it'll just be better. So I'm going to simplify this here. Zeros will simplify. 12 over 360 is 1/3 times 24 squared is 576. 576, a third of that is 192 pi. Okay, so again, that would give me the entire sector, that whole region that I just colored in blue. But now we need to find the area of the triangle and subtract that. So, triangle. 1/2 base times height. Remember, the base and the height have to form a right angle. No right angles in this triangle right now. When I look more closely at it, segment OB, 24 feet, that's a radius, and so is segment OA. So we have an isosceles triangle. I'm going to draw this a little bigger here since I'm on the iPad. Here's, stop. Sorry, guys. Here's A, B, O, 24 feet, 24 feet. This is 120 degrees angle O. I'm not going to write it in there because I don't have a lot of room, but what we're going to do is draw the altitude from O to AB. Remember, altitudes, perpendicular. if that's 90, in an isosceles triangle, when you draw it from the vertex angle, that bisects it. So this is 60, leaving angle B over here to be 30 degrees. So now we have this nice little 30, 60, 90. To find the area of this triangle, I need to know the base length, which is AB, and the height here, which is that altitude we drew in. Referring back to chapter 8 in our 30, 60, 90 rules, 24, that's the hypotenuse. Opposite of 30, this is the short leg. And opposite of 60, this is our long leg. In a 30, 60, 90, the hypotenuse equals the short leg times 2, which means our short leg has to be 12. So the altitude here is 12. In a 30, 60, 90, the long leg equals the short leg times the square root of 3. So that means this is going to be 12 square root 3. Which means that the entire base of this isosceles triangle is 24 square root 3. So back over here to the right side of the screen, to find the area of a triangle, we have to do 1/2 the base, 24 square root 3, times the height of 12. Half of 24 is 12. 12 times 12 is 144 square root 3. If I asked you, which sometimes we will, for the exact area of the shaded region, then the exact answer would be written 192 pi minus 144 square root 3 feet squared. That's the exact one. Now to find the rounded, like what it is asking us to do, then we're going to put that, just as I have it written there in the orange, in the calculator and round that to the nearest tenth. Which my calculator gives me 353.8 feet squared. Okay, exact answers will have pi and radicals left in them. Rounded answers, put it in the calculator and round. Woo! Number 6, another one. This time it says find the exact area of this shaded region. So it's very similar to number 5. If you want to try it here on your own, please pause the video and try so. I'm going to walk us through it here. We need to find, first, the area of the sector, which would give me all this inside those blue regions. See, doesn't that one look like a nice slice of the pie? And then I have to find the area of the triangle and subtract it, because when I subtract the area of the triangle here, I would be left with just what's in red. Well, red and blue right now. Okay, area of a sector. Now I've done this. This will be like the 3rd time on this side. It is your angle or arc measurement. Oh, that looks bad, you guys. Your arc measurement over 360 times pi r squared. So our arc measurement or our central angle measure here, those are going to be congruent. That's going to be 60 over 360 times pi, radius, halfway across the circle, is 12. Simplifying this, the zeros simplify, so we get 6 over 36, which is 1/6, times 144 pi. 12 squared is 144. 144 divided by 6 is 24. That's nice. So then the area of the entire sector, again, that would be all of this here that I just colored in, is 24 pi. Now we need to find the area of the triangle so that we can subtract it. Triangle. 1/2 base times height. Ooh, icky. Well, if I make this triangle bigger here, the bottom is 12. Since the arc measure is 60, then that means the central angle would be 60, which is this bottom left angle over here. Remember, the base and the height have to form a right angle, so I'm going to draw in the altitude perpendicular to the base. We already know that the base is 12. We just have to find our height, our altitude. When I drop that altitude in, I create this little 30, 60, 90 triangle. This is going to be 6 long leg, 6 square root 3. So now when I go to find the area of the triangle, we're going to go 1/2 12 times 6 square root 3. Oh, that was weird. 1/2 12, 6 square root 3. Half of 12 is 6. 6 times 6 is 36 square root 3. So then to find the area of that shaded sector here, in exact form, 24 pi minus 36 square root 3 centimeters squared. I'm not sure if you saw this or not, if you paused it and tried it on your own. Going back to this triangle, the bottom side is a radius, it's 12. The left side is also a radius because it goes from the center out, so it's going to be 12. We said this angle down here is 60 degrees because it measures with the arc measure. Now, if we go back and what we know about isosceles triangles, you guys, the base angles here that I just marked in black have to be congruent to each other. Triangle sum theorem is going to tell us that those two have to be 60. Therefore, all three angles are 60, so it's equiangular, which means it's equilateral. So instead of using 1/2 base times height, we could have used side squared square root 3 over 4. And we would still get the 36 square root 3. To practice, maybe you want to put that in the calculator and round it just to make sure you know what you're doing. If you were to round this exact area of 24 pi minus 36 square root 3, it comes out to be about 13.0 centimeters squared. Awesome. Okay, good luck. Email us if you have questions.